Good morning. So here we come again. We're going to start chapter 4 now. The beginning of chapter 4 is section 4.1 about antiderivatives. In antiderivatives, we will learn a technique on how to undo differentiation. So before we learned how to do x squared and we get the derivative 2x. Now what we are going to learn is what we call an antiderivative, which looks exactly like this. So for example, if I tell you that I know that f prime of x is equal to 2x. Can you tell me what the original function is before the differentiation? Of course, we know that the derivative of x squared is 2x. So we say the antiderivative of 2x is equal to x squared. An antiderivative of 2x is x squared. But to be honest, the derivative is unique. The derivative of x squared is 2x. But so is the derivative of x squared plus 1. So is the derivative of x squared plus pi. So is the derivative of x squared plus any constant you might think of. What are the derivatives of all of these? The derivatives of all of these are again 2x. So when I want to say the derivative is 2 of times x and I'm asking what was the original function, I cannot say the original function is x squared only, because this is not true. This is only part of the truth. The original function could have been x squared plus any constant it might be, because then the derivative would be 2x as well. So that's why antiderivatives are not unique. We have an infinite range of functions who are antiderivatives of 2x. How do those range of functions look like? The basic function, x squared. And then we have x squared plus 1. We have x squared plus half. We have x squared plus 2. We have x squared minus 1. We have x squared minus 10. And so on. So like these are a set of what we call a family of what we call pair functions. They are functions that do not meet each other, because if they met, then when will they meet? If they meet at any point, then x squared will be equal to x squared, which means c1 is equal to c2. So those functions, those family of functions never meet. Each function is generated by a different constant that we have over here. All these functions that I just drew and millions and millions and millions of others are family of antiderivatives of 2x, which are the family looking like f of x equals x squared plus c. As I said, those families never meet. Okay, they have the same shape, they have the same size, they have the same everything, but they are either shifted up or down. Either you add a constant so you shifted up, or you subtract a constant so you shifted down. All right, so that's why the antiderivatives do not look like just the basic function that you might think of. It is the basic function plus c, the constant of anti-differentiation that we have over there. All right, if two functions have the same derivative, then the only difference between them can only be a constant. Two functions having the same derivative, like over here, functions that have the same derivative should be functions that only differ in a constant. They cannot differ with something else, with anything other than a constant. Now, what is the notation for that? The notation we use for that is this notation. We say the antiderivative of a function is another function. We usually represent it as capital F of x plus c. The antiderivative of f is capital F of x plus a constant, as we just said. This is read the antiderivative of f with respect to x. What is the variable that we are going to consider as our derivative, as our variable of differentiation? X. So that's why the antiderivative of f with respect to x is, and this is called f of x plus c. So what does that mean? When do we have this relationship? We say the antiderivative of f of x is capital F if and only if the derivative of f is this function that we have over here. So the antiderivative of f is capital F. This means that the derivative of capital F is small f that we had over here. So in this case, what do we say? We say that the antiderivative of 2x with respect to x is which function? It's x squared plus c. The antiderivative of 2x with respect to x is x squared plus c. How do we really check that this, what we just did, is a right connection? We take the derivative of this side, it should be 2x over here. What's the derivative of x squared plus c? The derivative of x squared is 2x plus 0, it is 2x. So the antiderivative of f of x dx is capital F of x plus c, which means that the derivative of f of x plus c, which means the derivative of f is equal to f that we have over here. So instead of saying that the antiderivative of f prime of x dx is f of x, we call the function that we are getting the antiderivative for small f of x, and we call the antiderivative capital F of x. And this c, we call it the constant of integration. All right, this process, we can call it the anti-differentiation process, and some other people call it integration. And in integration, this we call it the integrand, and over here, this we call it the variable of integration, the variable of integration. You are integrating with respect to what? Variable. Now, just as we created in derivatives rules for differentiation, what was the first rule we created? What was the first rule that we created? We created that, the power rule. Let's start with the power rule. What did we do when we had a power in derivatives and we wanted to get derivatives? If we had a power and we wanted to get derivatives, what we would do is get the derivative of that, which is bring the power down as a multiple, x to the power n minus 1. So if I want to think what my steps are, first I will multiply by the power. Second, I will subtract 1 from the power. All right, this is the power rule of derivatives. What I want to do now is I want to create the power rule of antiderivatives. Anti means going backwards. It means that we are going to undo what we have done before. To undo something, if I walk one step, imagine you are doing that. If you walk one step, then you walk on another step to form 2 steps in total. How do you go back to your original place? This is step number 1, this is step number 2. What do you have to undo first? You have to undo step number 2, and then you undo step number 1 in order to be able to go back to the original place. That's the way we think about it. So now that's what we're going to do. If we had a power answer and we wanted the antiderivative of that, what should we do? First, we should undo what we did second. Our second step is what we go back with first. If we subtract 1 from the powers, what should we do to undo subtraction? We add 1 to the power. Second, what do? You have to undo the first step. So you undid the second step. Now you have to undo the first step. What was the first step? Multiplying by the power. What is the undoing of multiplication? You have to divide by the new power because you added 1. The answer, after you added 1, we will call it the new power. What do we do with it? We divide by it. So now if I want to apply this in general, if my integrand is x to the power n, then what will I do? I will first add 1 to the power. It becomes n plus 1. Second, I will divide by this new power. What is the new power? N plus 1. Of course, we always add the constant of integration. Let's really check if this is true. Let's assume I wanted the antiderivative of x cubed. According to this formula, I need to add 1 and divide by the new power plus c. How to check that my answer is correct? We check antiderivatives with derivatives. What's the derivative of x4 over 4 plus c? 1 over 4 is a constant. The derivative of x to the power 4 is 4x cubed, and the derivative of the c is 0. What does that give me? It gives me x cubed. Is that true? The antiderivative of x cubed dx is equal to x4 over 4 plus c. It's true because the derivative of x4 over 4 plus c is nothing but x cubed. So this is our first formula that we have done over here. We have shown that the antiderivative of x to the power n dx is xn plus 1 over n plus 1 plus c. This is how we work it out. This works for all n except minus 1. The only n that it doesn't work for is minus 1. Why? Because if I want to do x to the power minus 1 plus 1, I'll get 0. And I cannot divide by 0 because there are two steps. First you add 1 and then you divide. When I add 1 to minus 1, the answer will be 0. Can I then divide by 0? No. So this formula works for all n except minus 1, which makes sense. Why? What is the antiderivative of x to the power minus 1? dx. When the power of x is 1, it's no longer a power problem because x to the power minus 1 is what? Is as if we have 1 over x. And this is the antiderivative of what function? If I want an antiderivative for 1 over x, what function when you differentiate it gives you 1 over x? Exactly, it's not a power, it is, and we'll keep it for later on. But just a heads up that when we have a power of minus 1, this is not necessarily a power. It's not a power. It's treated in a different way, and we always have to keep it in mind. We always have to remember that this is the case that we have. Let's continue. So this is one of the basic formulas. All right. Let's try examples. What do we do when we have such a thing? I have to change it just like I used to do in derivatives. I have to change it into a power form. What does this look like in a power form? It looks like x to the power minus 3. Does it apply on the power rule of antiderivatives? Yes. What do? I add 1 and divide by the new power, and I do not forget the integration constant. So this becomes minus 1 over this x to the power minus 2 has to go downstairs so that we have a positive power plus c. Another example, let's assume we have integral of root x dx. Then again, what is our first step? We write it as a power in terms of x to the power n. You add 1. What is 1 plus half? 3 over 2. Now see, you have to divide by 3 over 2, but dividing by 3 over 2 causes me to have a nested fraction. We should always remember that when we want to divide by a fraction, it's the same as multiplying by the reciprocal of that fraction. So I reciprocate it and I multiply by 2 over 3 plus c. So instead of dividing by 3 over 2, I multiply by 2 over 3. Another example, integral 1 over cube root of x dx. This is written as x to the power minus 1 over 3, which means again I need to add 1 now. What's minus 1 over 3 plus 1? 2 over 3. I need to divide by 2 over 3. Instead, I multiply by 3 over 2 plus c. I'll be back in a second.